Let's talk about the root test. The root test is very similar to the ratio test. Um, and perhaps the root test should really be called the nth root test rather than just the root test because we're not calculating a square root. We're going to calculate something a little bit different. So here's what we're going to do. Just like in the ratio test, we're going to have to calculate the limit of something. It's going to be the limit as n goes to infinity of what we're going to do is we're going to take the general term an, take the absolute value of that, and then calculate the nth root. The nth root meaning the root of index n. And we're going to call this limit a number. We're going to call it L. And similar to the ratio test, if this L is less than 1, that means that your series AN is absolutely convergent. Okay. If we calculate the same limit as n goes to infinity of absolute value of AN, take the nth root, call that number L. But if it's bigger than 1, just like with the ratio test, this means that your series AN is going to diverge. And we've covered the case where L is less than 1, it converges. L is bigger than 1, it diverges. So the natural question to ask is, let's say you calculate the limit as n goes to infinity of absolute value of the general term an, and then you calculate the nth root, called that number L. What happens if it's equal to 1? Well, in this case, that means that the test is inconclusive. Okay, so when the test is inconclusive, that means we need to try another test. Try a different test. So maybe you need to run a comparison test or an alternating series test or a limit comparison test or an integral test, something like that. Regardless, you need to try something different. Okay, so just like with the ratio test, I mean, the test is super powerful in that it tells you at absolute convergence, but it's got this glaring weakness of having an inconclusive case. So let's take a look at example 4. When we look at example 4, one of the clues that tells me I want to use the root test is my general term is really some expression all raised to the nth power. So when the whole thing is raised to the nth power, that's a clue that I want to use the root test. Okay, so this, expression to the nth power is a clue to use the root test. All right, cool. So let's use it. So what we need to do is we need to calculate the limit as n goes to infinity. I want to take absolute value of the inside. So the inside is the expression 3n plus 2 over 4n plus 3, quantity all raised to the nth power. We put absolute values around that general term, and then we're going to take the nth root. Okay, so now we can see that you have something to the nth power, that's raised to the nth root. Let me fix this so it looks less like a h and more like a n. And then when you have a power to a power, you got to multiply the two powers together. And n times 1 over n is just 1. So the result is going to be we're going to get the limit as n goes to infinity. And you're going to have absolute value of 3n plus 2 divided by 4n plus 3. Okay, now I have absolute values there, but every term is positive. So, inside is positive. So I can really drop the absolute values. So let me do that. I'm going to take the limit as n goes to infinity. I can drop the absolute values. So I just have 3n plus 2, which is positive, divided by 4n plus 3, which is positive. And what I'm going to do is I'm going to multiply top and bottom by 1 over n, which is the highest power in the denominator. You could use L'Hopital's rule if you wanted to, because you would get infinity over infinity. But let's just do it this old school way. We get the limit as n goes to infinity. You're going to get 3 plus 2 over n divided by 4 plus 3 over n. Remember, you have to distribute this 1 over n to both terms. Distribute this 1 over n to both terms like this, and then we arrive at this result. Now, when I take the limit as n goes to infinity, the 2 over n is going to go to 0. The 3 over n is going to go to 0 because the top is constant while the bottom is exploding. Again, the top is constant while the bottom is exploding. So in the end, we're going to get 3/4. This is our L. And this is less than 1. Okay. So let me just mention that this guy right here, this is equal to our L. So I guess we could just state by the root test our series is absolutely convergent or absolutely converges. Okay. All right, everyone. Take care.